All right, let's take a look at one problem. A businessman invested part of his $40,000 end-of-the-year bonus in an international fund that paid an annual yield of 8%. The rest of the bonus was invested in an offshore bank that paid a 9% annual yield. Find the amount of each investment if he earned a total of $3,415 in interest in the first year. Now there's a lot going on here, but we're going to start this like any other word problem with our let statements. What are they asking us to find? They want us to find the amount of each investment. The first investment was in an international fund, and the second was in an offshore bank, so those will be our let statements. Let the amount invested in the international fund be X, and let the amount invested in the offshore bank be Y. Even though we're looking at problems that are a little bit more involved than the ones we did before, we set up the let statements in the exact same way. We figure out where in the problem they're asking us to find something, and we express the unknown quantities as X and Y. You should be able to do this first step even if you don't know anything about investing or interest or offshore banks. We are prepared to do this first step always. Now, next, we need to set up a system of equations that we can solve. But before we do that, I'm going to organize all of our information in a table that's going to help us figure out what those equations are going to be. Now, this is something new to us. We haven't done this in word problems before, and so it's going to feel a little weird the first time. But we're going to do this for all the interest problems for this lesson, all of the mixture problems for the next lesson, and all of the motion problems for the following lesson. So after we've got several examples and we've got a lot of practice with this, it's going to be much easier and it's going to feel much more natural. Now, the relationship that we deal with when we're dealing with these interest problems is that the principal times the rate equals the interest. And we're going to set up a table like this every time we do a simple interest problem. All right. The three types of information we'll be dealing with are the principal, the rate, and the interest. So they each get a column. And furthermore, we know that the principal times the rate gives us the interest. So we're going to write that in the top. Now on the left, we're going to label those rows with the two different types of accounts that we're dealing with. The first one is an international fund. An international fund. I'm going to abbreviate international INT''L just to save space. And then the second one was the offshore bank. I'm just going to label that offshore. And we're going to want to fill in all of the cells in this table. So let's start with the international fund. Do we know the principal, the amount that was invested in the international fund? Well, that was an unknown, and so we decided that that would be X. So we're going to put X here. Similarly, with the offshore fund, we didn't know what the principal was. That was an unknown quantity, so we decided to represent that with Y. So we're going to put Y here. Now let's move on to the rates. What's the rate for the international fund? Well, we're told that that had an annual yield of 8%, and 8% as a decimal is 0.08. So that rate is going to be 0.08. For the offshore bank, that was a 9% annual yield, and as a decimal, we express that as 0.09. Now, we don't know how much interest was earned in the individual accounts. We know the total interest, but not the interest for each account. But we know that we can figure out interest by multiplying the principal times the rate, and that's what we're going to do in each of these rows. In the first one, the principal times the rate, x times 0.08 is going to give us 0.08x. And then in the second one, the principal is y, the rate is 0.09. When we multiply those across, we get 0.09x. I know that this might feel weird, especially since it's the first time that we're doing this, but don't worry. For all of the interest problems, for all of the mixture problems, for all of the motion problems, for 3 classes, we are always going to take whatever's in the first column and multiply it by whatever's in the second column to get whatever's in the third column. This feels weird right now, but it's going to feel natural as we go through example after example after example. They all work the same way. Now there's 2 pieces of information we haven't used yet, $40,000 and $3,415. $40,000 represents the total amount of money that he had to invest. So that's going to be the total principal, and we're going to put that at the very bottom of the principal column. And this actually is going to give us our first equation. We don't know how much he invested in each of these accounts. We're representing them with X and Y, but we know that the total investment was $40,000, so that means X plus Y has to equal $40,000 in total. That $40,000 ends up being a part of our first equation. And the $3,415 is going to be a part of the second equation. This represents the total amount of interest, so we're going to put that at the bottom of the interest column, 3,415. And we know that the interest from the first account plus the interest from the second account gives us our total interest. So the second equation is going to be 0.08x plus 0.09y equals 3,415. In general, for these problems, the first column is going to give us the first equation, and then the last column is going to give us the second equation. We will see some examples where that's not going to be the case, but that's far down the line, far along the line. In general, these problems are mostly going to work out the exact same way. So now we have our system of equations, and we can solve for x and y. We're going to use substitution here. Substitution is going to be a little bit easier because elimination with decimals becomes a bit more work. So we want to isolate one of these variables. You can choose either x or y. It doesn't matter. You're going to get the correct answer either way. However, there is one that's going to be a little bit less work. If you look at the other equation, whichever variable has the smaller coefficient, in this case this will be x, because 0.08 is less than 0.09, it's going to be easier if we isolate that variable in the first equation, simply because it's going to allow us to have fewer negative signs in the answer. So let's get x alone. If we've got x plus y equals 40,000, and we want to isolate x, we need to subtract y from both sides. And if we do that, that's going to give us x equals 40,000 minus y. Once we have this, we can substitute this into the other equation. So we've got 0.08 times x, but we said x was 40,000 minus y, plus that 0.09y equals 3,415. We can distribute this 0.08 next. 0.08 times 40,000 is 3,200 minus 0.08y plus that 0.09y equals 3,415. Next, we can combine like terms. 0.09y minus 0.08y is 0.01y plus that 3,200 equals 3415. To get the y term alone, we need to subtract 3200 from both sides. Doing that gives us 0.01y on the left, and on the right, 3415 minus 3200 is 215. Then to get that y alone, we divide by 0.01. 215 divided by 0.01 is going to be 21,500. You'll notice that I'm not writing out every individual step of my work. My hope is that at this point, you can see exactly what we're doing each of these steps without writing them out. We have now spent several weeks solving equations, and the hope is that we have enough practice solving equations that we can get through them without writing out our work for each step. We're still writing out the new equation each time, but I'm not actually saying minus 3200 on both sides divided by 0.01. The reason we want to avoid writing out all of this is because now we've got a large problem with many steps, and if we're taking the time writing out each of these little arithmetic steps, it's going to end up taking a lot more time, it's going to take a lot more space. We want to focus now on writing out the things that are new and more challenging for us. Anyways, we know now that y is 21,500. We can plug that into this equation now to figure out what x is. So x is 40,000 minus y. We know that's going to be 40,000 minus 21,500. And 40,000 minus 21,500 is 18,500. So we know that x is 18,500. We can circle back to our let statements and plug those in. We've got 18,500, and that's dollars. And for y, that's going to be $21,500. And our last step is to state our conclusion. They said to find the amount of each investment. So we can say that they invested $18,500 in the International Fund and $21,500 in the offshore bank. And that is our final answer. These problems take time to solve. We are 13 minutes into this video. I want you to go through the other examples slowly and carefully, writing out your let statements, setting up your tables to organize the information, writing out your equations that model the situation, solving the system of equations, and stating your conclusions in the end. Go through the first video, step by step, watch the video, follow along as you do it, and then attempt the other videos on your own, and then watch the video to verify that you've done each step correctly and learn from any mistakes that you might have made.